Yo, I didn't call before because I was listening to the pizza. Oh yeah, sweet brother. We'll see you soon. See you soon. I've almost got my sim set up actually pretty good now. I've just got to fix my pedals. I raced to get to the Nordschleifer. Forgot I added a clutch and went straight into the wall at full speed. Death. Do some Ossetto, eh?
car is towed. You'll need a tow back to pit lane. Press and hold the reset button and we'll come and get you. You've upset the officials with your slow driving. Lap times will be deleted until you reset the car and try again. to go. Next time by. The estimated strength of field is 533. Line up on the left side. Pit road is closed right now. Let's go points racing. Still waiting on 2 cars to grid. Catch up and car. Left up 10, car by. There's an incident behind. You've got wheel damage. Get ready, going green. Catch up 10, car. We got damage on the front end. The pace car is off, be ready. Catch up 16, car. Catch up 19, car. We got damage on the front end. Green, green, green. All the damage is repairable.
Copy that. We'll see you soon. Nuh-uh. Fucking just got your license. Don't go losing it or dying. I'm just fixing my shit. You can listen to the YouTube video I'm watching. Don't watch this fucking YouTube video. Good man.
It's always fun when you have to do something 10 times instead of 1 time. Gives you more time to regret your decision. I just got this box in the mail, and it has a set of 10 compute blades. Now, last time I talked about these things was in April of 2023, and that's when I ordered a set along with a mini rack case, some fans, and custom heatsinks for the Compute Module 4. That whole bundle set me back about $1,000. Since that time, the Compute Module 5 came out, and more than 2 years have passed. And these custom heatsinks, they're useless on the newer Model Pi. And now there's a new kid on the block, this shorter Xerxes Pi. It does the same thing, just with a little different design philosophy, and for less than half the price of the Compute Blade. And guess what? It's on Kickstarter too. I ordered a set, and to be transparent, both of the companies behind these boards sent me samples either before or during their Kickstarters. That's the reason I'm marking this video as sponsored, even though no money has ever exchanged hands, except for me paying $1,000 to Uptime Lab for the Compute Blades and $50 to Xerxes Pi, which I haven't gotten any blades back yet for. This video is a tale of 2 Kickstarters, 2 Pi clusters, and today I'm going to build the biggest Pi cluster I've ever owned, a $3,000 160 gigabyte of RAM Raspberry Pi cluster. I want to see, are these things even relevant anymore? Oh, and I should mention, the Compute Blade and all its accessories are available on PiShop now, so the saying remains, good things come to those who wait, and a fool and his money are soon parted. My goal today is pretty simple. I want to put together this 10-node Raspberry Pi cluster with, I bought 10 of these. This was probably an unwise decision for a purchase, but I bought 10 of these CM5016000, which is the 16 gigabyte of RAM Compute Module 5 with no Wi-Fi, I think, and no eMMC. So basically like the base model with the most RAM. So we're gonna put all these together, put together a 10-node Raspberry Pi 5 cluster and see how it performs. I actually have an ulterior motive for this, and probably by the time you're watching this video, you'll know what that is, because that video will probably go up before this video. But yeah, here's, oh gosh. There's a lot of these heat sinks, which unfortunately I will not have any use for because I am going to be running Compute Module 5s, and these are custom built for Compute Module 4. Here's some blades. And at the bottom, this is our cluster holding rack mount for 10-inch racks. Hopefully this fits a 10-inch rack. I haven't even checked that. The Xerxes Pi is a much shorter board. You can see that there's a substantial difference right there. And yeah, so this one, the Xerxes Pi might fit your needs better if you need the compact space. But there are some advantages to the way the Compute Blade is designed, and maybe we'll get into those. But at this point, I might time-lapse this, I might not, but let's start building these blades. I guess for the first one, I won't time-lapse it. I'll let you see how this all goes in case you want to replicate the setup. And it looks like there's a bunch of stickers in here too. There's some fun little stickers. How wonderful, we'll put those aside. I have a feeling we're gonna have a lot of those stickers today. Yeah. All right, get these ESD bags out of here. And put the boxes over here. Okay. So there's probably directions for this somewhere, and I'm not gonna look those up. I'm just going to assume that this guy is a pull tab for up here somewhere. But the question is, how does this go on? Okay, so the M.2 screw, there's like a little mount here. There's a little screw hole up here that you put the M.2 screw inside of. And then the actual screw to hold an M.2 drive is also included. And they have a little screwdriver here too, which means I'm gonna have 10 of these itty bitty screwdrivers sitting around after this is done. So that's that. And then these guys, how does this go? There's probably a guide. I'll look up the guide. Getting started, here we go. So there is a little link here. Let's get to it. Okay, press them firmly together until they latch. Ow, okay, well, that's latched. Oh, I see. Okay, so this is like a little switch. So now, oh man, this is gonna take a little while. I'm gonna go ahead and use my iFixit toolkit just because there's a lot of these and it's gonna get annoying fast if I use these itty bitty screwdrivers. It's always fun when you have to do something 10 times instead of 1 time. Gives you more time to regret your decision. Okay, so we got that together. And then there's these little covers on the screw holes here. You can screw in the compute module for more security, but I'm not gonna be doing that. And apparently these little covers, I didn't know this until recently, these are put onto these things. A lot of devices have a little cover on it that's used for the little vacuum pump that holds the device while it's placing it on the pick and place machine. So a lot of different connectors have a little piece of Kapton tape on it just to provide a flat surface for that. So interesting tidbit that I learned, and now you know if you didn't know. Let's get out a compute module. There it is. This is an entire computer called, oh, that's upside down. An entire computer on a module. It's called a system on a module, and it uses these 2 connectors to connect to the board. And this should just work here. Now, I'm not going to use their heatsink. I'm just going to rely on airflow, active airflow cooling over this thing when it's inside of the rack mount case. We'll see how that works. This is, I think these are dev blades. No, these might not be dev blades because there's not a USB-C port down here. So when you're putting these together, you want to flash an operating system to either a micro SD card, which, oh gosh, I just realized I don't have SD card slots. So how am I going to boot this thing? I don't have eMMC. I'm going to have to use NVMe drives, which I don't have on me right now. So I'm going to have to pause on the rest of this assembly. I'm just going to put these together this much. And here's what I was going to do. I was going to use this little bandolier of micro SD cards. You can see I used Raspberry Pi Imager and flashed blade 1 to blade 10 on these. And I was going to put these into the blades, but I realized I don't have the dev blades, and the dev blades have SD card slots. My blades don't. And I'm going to have to find some NVMe storage for this and flash it that way. NVMe storage is a lot more expensive, but it is more reliable. So if I'm going to run this cluster for more than a day, that's nice. Anyway, there's our first blade. I am not going to sit here and do this and make you watch the entire thing. So I'm going to go very fast and speed up and maybe even put in a little background music. We'll see. Well, that was a lot, and I'm gonna have to pause there because my recorder is under 1 minute of recording time left. So I'll be right back. Hey, it's me. I'm coming from this side of the table, which is a little bit different. I got my pile of the compute blade boxes, pile of the compute module. Well, there go those boxes. And there they are. They're all put together now. And I realized when I was putting these together that two of them, these two, are actually dev blades. You can see the difference is that it has a few more features on it. It has like a TPM module. It has a USB-C port for programming. It has the SD card slot, which I thought that I had on all of these, but I do not. So I'm going to have to find some NVMe drives and put them in here before I start racking them up. And there's one other part to the system, these fan units, and I think I bought the dumb fan units. They have smart ones and dumb ones. And I'm kind of dumb, I can't even open this box. There we go. There. There's PCB. There's a space on this PCB on the other side for a little Raspberry Pi RP2040 microcontroller for smart fan control. But this one is just the one that like gives power to the fan. And these are the fans, they're Noctua. So they're not going to be super loud, but they will be a little louder because I think it just runs them at 5 volts. I think these are 5-volt fans, and they just clip into the back of here. So there's one fan unit, so that's why there's 5 of those, for 2 compute blades. I'm going to try to find, I don't know, maybe I'll just like pull a bunch of NVMe drives out of different projects I have going on and flash them for these. That'll be more performant and more reliable than microSD, but it's certainly a lot more space to take up. And I thought this was just the coolest thing, a little bandolier of microSD cards, which I will now not be able to use, even though they're all flashed with the host name and everything on them already. Oh well, that was a waste of 30 minutes. But it's never a waste when you learn something. I don't know what I learned. I learned that it's fun to put microSD cards like this, I guess. So I did manage to find a number of these NVMe drives. I think I have 10 here. And my method here is pretty ridiculous. I have this little USB little adapter that I can pop one into. And after I flash it, I take it over here. This is number 2. And I stick it on number 2. So we'll go down from the top, 1, 2, 3, 4, etc. So I'm going to do that for these, and then we'll have OSs, and hopefully these all work. I haven't tested all of these NVMe drives on Raspberry Pis. Sometimes the PCI Express bus can not handle certain drives well, especially higher power drives. So here's where we currently stand. I had some of these blades up and running, and then they started disappearing from the network. So I don't know what's going on. I have my 2 PoE switches here that I was going to be using. I was going to connect them together using one of these. This is a DAC, a direct attach cable. And then I was going to get the internet into here, or the network into here, and start clustering them and testing them. That's not going to happen before I have this other video project that I'm working on. So I'm going to have to shelve this, which is a little unfortunate. I'm not sure what the problem is, but by the time we finish this video, either none of these will be working, or I'll get them all working, or maybe some of them will be working. But that's one of the fun things that happens when you're dealing with many computers. When you have one problem, you tend to have more than one problem. So anyway, I hear my 3D printer going back there for the other project I'm working on, and we'll get back to this. I got to clean off my desk because there's a huge mess here, and I just don't have time to finish this cluster build before the other cluster that I'm testing it against. So can you guess what the problem was? The problem, well, I mean, the root cause analysis is probably that I was a little too stressed and overworked at trying to finish 2 cluster builds in one day and benchmark them against each other in one day, because clusters always turn into more work than you expect. But the actual problem here was that I didn't have the right network cable plugged in on my switch that went back to the main rack, and so I was not able to see the cluster from my main computer, even though the port on the switch was showing activity. That was just activity to like its own little local network. So, oops. Yeah. So anyway, let's get back to the cluster build now. So long story short, I decided to buy all new SSDs for this cluster instead of relying on a hodgepodge of all the SSDs I found laying around the studio. And that meant paying another $200 for these 256 gig Patriots. I wanted enough storage to hold a medium-sized AI model, but not so much I go bankrupt making this video. So again, I got to take all the blades out, swap out all the drives, put them all back in, reattach the fan units. I mean, at some point I could probably do this blindfolded. And this time I also decided to print out labels for each SSD so I don't mix them up as easily. The one good thing about NVMe, I guess, is they flash in like 10 seconds instead of 30 seconds to a minute like my microSD cards. But I put in all the new drives, reinstalled all the blades, reinstalled all the fans, reinstalled all the patch cables, and booted it back up. And this time, with the new drives installed and the network cable plugged into the right port, things actually worked. I could ping all the Pis using Ansible, and so I moved on to finally benchmarking the cluster. And I'm sorry in advance to all you Index at 0 folks. Yes, I started at blade 1. And yes, that means every time I'm running playbooks, the 10th blade is out of alignment with the rest. I'm sure your disappointment is immeasurable, and your day is ruined. But on to the high-performance Linpack benchmark. This is my favorite cluster benchmark because it's the traditional benchmark they'd run on massive supercomputers to get on the top 500 supercomputer list. And after like an hour, this cluster scored a respectable 275 gigaflops. A single 8 gig CM5 gets about 32, so an 8.5 times speedup for the 16 gig model is pretty decent. But I did notice after spiking to around 140 watts of power, the cluster settled in around 105 watts during the run. And that made me wonder, was this thing throttling? Yes. There's not enough airflow without heatsinks to keep the CM5s cool. So another $70 later, I had these 10 heatsinks, and I got to pull out all the blades again. And the first time I put on the heatsinks without screws, thinking the thermal pads would just hold the heatsinks on, but after one fell off, I thought better of it. So I took them out again, popped the heatsinks off, put in screws, and screwed it all together. Isn't clustering fun? So finally, it was time for another run, this time with the thermals hopefully in check. And yes, it made a pretty significant difference. The cluster ran around 130 watts instead of 105, and the end result was about 325 gigaflops, which is a straight 10x performance improvement over a single 8 gig CM5. That's more in line with what I was hoping. And now we get to why I wanted to run all these benchmarks. I know the framework cluster I built last month is faster. I mean, there's no comparison running 64 AMD Zen 5 cores against 40 puny Pi 5 cores. But could this cluster be more efficient? Or could I get better performance per dollar? Well, yes and no. 4 framework desktops running the Ryzen AI Max Plus chip are almost 4 times faster than 10 CM5s. But the CM5 cluster is more efficient, even accounting for the 2 network switches versus the one I used with the frameworks. So assuming we could cram in a few more Pi clusters in a single rack, maybe we just scale up density and we can win in price? Well, no. The framework cluster gives us about 0.14 gigaflops per dollar, while the Pi cluster gives us 0.11. That's not too far off, but that's also accounting for my Kickstarter pricing for the compute blades and not counting shipping costs for either cluster, which can vary depending on the day of the week, especially if you live in the US. So all things considered, it's not a clear win overall, but having fewer beefier nodes can be an advantage depending on what software you're running. So next up, I was going to run some AI clustering benchmarks. With 10 16 gig CM5s, I have 160 gigabytes of unified memory, right? Well, sort of. The CM5 does support Vulkan, so theoretically you could run llama.cpp using the iGPU. But in reality, there are quirks since the Pi's Broadcom chip is a little different. And that means I could only get CPU inference working. And I mean, it works, it's just not fast. Like one of the smallest models that might be useful is Llama 3.2 3B. And running on just one node, you can get about 6 tokens per second. That's slower than most N100 mini PCs. But one thing you can do on here is have 10 separate instances going, like if you wanted to have 10 completely private small AI models. But that's a pretty niche use case. Also, you could only run 10 at a time if all 10 nodes are working, which around this time I also started having some reliability issues on node 9. It kept shutting down every time I would run a benchmark. Was it a power issue? Maybe a bad solder joint? I'm not sure. I tried plugging it into different ports using different cables, but it kept flaking out. So I decided to drop it out of the cluster, and I'll try to figure out what's going on with it later. So anyway, with 9 nodes and no Vulkan, I started benchmarking AI in my Pi cluster. And to start off, I tested a fairly large model, the Llama 3.3 70 billion parameter model at Q4 quantization. Now, using llama.cpp in clustering mode, it uses a method called RPC. And the way it's implemented, well, you might already see the issue here. It goes round robin style. Basically, it takes a big model, like the 40 gigabyte model that we're testing here, and splits up layers on all the different Pis. Then it will call out to each Pi, one after the other, to process the prompt and generate a response. And that's slow. Like, it's actually going to be slower than if you just ran it on a single Pi. Of course, you can't do that, and that's why you cluster them in the first place. Since the model's 40 gigabytes, it can't run on a single compute module, and that's why we have a cluster. So it's a trade-off. And in this case, a trade-off that is very slow. Like, after a couple hours, I finally got a result for just the prompt processing. Apparently, it crashed out when it tried generating a response. But just looking at the prompt processing speed, this cluster is like 30 times slower than the framework. I reduced the number of tokens so my benchmark would run on here, and generating just 16 tokens, I got a whopping 0.28 tokens per second. Yikes. At least that's only 14 times slower than the framework cluster. I was gonna try loading up the 60 gig GPT OSS model, but I value my time. I did want to see if either EXO or distributed llama would run any better. They're more limited in what they can do, but other people with Raspberry Pis seem to get better performance with them, so I gave them both a try. First, with distributed llama, I tried running the same 70 billion parameter model, but found out there's a limit to how many nodes you can throw at it, at least with the way dllama works. I had to limit it to 8 of the blades instead of 9 or 10, and that let it load the model in. Running it that way, I got 0.85 tokens per second, which, okay, that's not horrible. It's still 5 times slower than the framework cluster, but if you're that sloth guy from Zootopia, maybe you could live with that. But EXO is supposed to be all fancy and self-aware and self-healing and stuff, so I ran it, but it had a lot of janky output just trying to download a model. That didn't inspire much confidence, but I waited for like 2 hours for it to download this tiny model, and all I got were these errors, even if I dropped down to just like 2 or 3 Pis, so I gave up on EXO. I was also going to test the Xerxes Pi blade, but I was told the prototype unit I was sent has a power delivery issue, so I'll put that on pause for now. I'll drop a link below where you can follow my testing progress on the Xerxes Pi. Bottom line though, this cluster's not a powerhouse, and dollar for dollar, if you're spending over $3,000 on a compute cluster, it's not the best value. What it is efficient, quiet, and compact. So if density is important, and if you need lots of small physically separate nodes, this could actually make sense. Like, the only real-world use case besides like learning and education is for CI jobs or high-security edge deployments where you're not allowed to run multiple things on one server. That's what Unredacted Labs is building Pi clusters for. They're building Tor exit relays on blades after they found the Pi was the most efficient way to run massive amounts of nodes. If your goal is efficiency and node density, this does win, ever so slightly. But yeah, for like 99% of you watching this, this is not the cluster you're looking for. And it's interesting, 2 years ago when I ordered these blades, a company called Gateworks reached out. They were selling a souped-up version of the compute blade made to an industrial spec. This G-Blade is around Pi 4 levels of performance on the CPU, but with 10 gig networking along with a 1 gig management interface. But it's been discontinued. It doesn't look like any blades out there are really lighting the world on fire. And like the Blade movie series, the Compute Blade is more of a cult classic than a mainstream hit. Now, all this doom and gloom isn't to say this is a bad cluster. I'm going to see if I can get Blade. Last month, I helped kick off the SBC Cluster Competition, where students from more than a dozen universities competed to build the best single-board computer cluster with a budget of $6,000. I went through my own history with SBC clusters, like these ones with Raspberry Pis or Rockchip boards, and then I got to see some of the clusters the students were running. But that whole thing reminded me it's time to test DeskPi's new ITX cluster board, the Super 4C. And by the end of this video, I'm going to see how my cluster stacks up against all the student clusters in performance and efficiency. The Super 4C solves two problems I had with their older Super 6C, namely remote management and network bandwidth. For remote management, they integrated an ESP32 microcontroller so you can power on and off individual nodes and monitor everything over Wi-Fi or eventually Ethernet. And for bandwidth, they now offer a 1 gig and 2.5 gig Ethernet port direct to each Pi. They still kept an M.2 slot for each Pi on the bottom and exposed GPIO, camera, fan, and RTC battery connectors on each node. And you can boot from USB 3.0 on the back, an NVMe SSD, or if you have a light compute module, one of these microSD card slots. Finally, each node has its own USB-C port for flashing eMMC modules and micro HDMI for display. I've covered a ton of Pi clusters on this channel, like this tiny nano cluster, and I still have more I haven't covered yet, like this even more dense 8-node Xerxes Pi cluster. But the Super 4C is about the closest I've seen to a Goldilocks cluster, giving just enough features like redundant power supply inputs and 2 network connections per node without getting too expensive or complicated. It's close to perfect for like students serious about learning HPC in a tight space and on a limited budget. In this video, I'm also testing this new all-aluminum mini rack, the Home Rack from Waveshare. More on that later. But back to the cluster board. It's going to run you $210, and that includes a power supply. Add on 4 basic compute module 5s with eMMC, and the whole cost for a cluster like this is around $560 minimum. With my 16 gig CM5s at today's prices, this would be almost $1,400. That's not cheap. But lucky for me, I bought mine over a year ago, and they were about a third of that price. I will say, if you're building a little home lab on a budget, just go buy a mini PC with 16 or 32 gigs of RAM and run Proxmox. This cluster board is built for learning in HPC. It's not really a budget option for home labs. But back to the board again. You can install up to 4 compute modules and run either passive heat sinks like I'm using here, or heat sinks with built-in fans for better cooling. The front side has 2 banks of 4 Ethernet jacks. One set is 2.5 gig ports that are routed through the Pi's USB 3 bus. The other set is 1 gig ports that come straight off the Pi's built-in Ethernet NIC. There are 4 separate power rails which can be controlled independently, and those come through redundant 19-volt barrel jacks. The board will automatically switch to whatever connector has the higher voltage. Now, I mentioned Waveshare has this new mini rack, and I just happened to get this prototype of it in
When did the things we use get sad? Like, when did phones get so boring? A million options of the same fragile glass slab, and all of this mass-produced by the millions for a target audience of literally the entire Earth. Blah blah, don't care. Sorry, I almost became one of those depressing documentary channels. Anyways, I just want a silly phone. Yeah, that's enough reasoning.
Dude, you should sell it.
This is the Galaxy Z Flip. Hate on it all you want, but you know what? At least it's interesting. Just some of them are a little sad. But you know what a little sad means? That's right, dirt cheap on eBay. And it's the perfect form factor. And by perfect, I mean anything but a rectangle. Now I was just gonna make a new enclosure, slap my logo on it, and call it a day. But what am I? A reasonable person that likes to sleep? Nah.
Oh.
Yeah, I'm cutting it in half. Wait, what? No. I mean, look, everything's basically already in 2 pieces, so all I gotta do is just split the 2 halves.
No brace mats. Yo, bro. Try this brake curve calibration. That feels... Dude, look at me. Maybe that needs to... Let's see how that feels. Oh, oh. Stole it. Oh no. Ooh. Interesting. I know. That's why I'm doing so bad. Let's go 100% turbo. Well, bro, these new my new pedal setup's cooked, eh? It's so hard to get used to new pedal arrangement. Let's try more fucking reasonable fractal learner, man. That's crazy. And oh, bro, my fucking Moses shit's not set up either. Hang on. Okay, that's what I now. Really need a sequential, need a manual shifter as well. And the way just stop my freaking thing from shifting me. I doubt I can take that. Oh, dude, you gotta fix that. That's not good. It's actually age you can't change the field of view, not in the freaking thing. Hmm. What the fuck's Neck FX there is? Yeah. Never been a big Holden guy. It's not even M3. Where the hell? Oh, my handbrake's on the wrong side. God damn it. New glass. That did look pretty good. But it has to be even more than that. That's hectic. Oh, let's change the weather as well. Need to make more shit. Oh no! Cancel. Cancel, cancel, cancel. Fuck. Oh, bro, what have I done? Can't see shit. Lots of reds. I've been very light. Lightly. Fucking hell. Okay. Oh, bro, that's... Oh! Bro, that is the worst decision I've ever made in my entire life. Also, that neck FX is way too aggressive. Yeah, still getting used to the... Oh no, the fog's still on. Right. Because I turned fog on. Let's go... Why am I being retarded? Copy that to you, Bastion. Fuck, bro, what's up with these clutches? Bro, fucking hell. Bro, that's so... Bro, that needs to be turned off. I feel sick already. Need first there. Oh yeah. Thanks, bro. Steering wheel's clapped. What's up, brother? Dude, it's very hard. I can't fucking get the gears I need. See how we go here. I'm actually probably gonna bite the bullet, I think, and turn on pant steering wheels. Where the fuck is the steering wheel? Where can I see the steering wheel? Alright, pressure's on. I do have S15, but I just need that one's got a little too much power. Let's get something slow. I don't have this one. Alright. Stop. I don't have. I've got I've only got one. I can either use a handbrake or a shifter. I'm trying the handbrake out. Fuck's sake. Bro, why'd you tell me to do a togi for my first one? This is hard. I should have started with Drift Playground, to be honest. I'm gonna download that in a sec. So I can just practice my technique. Bro, I don't know what's happening to the wheel. Ah! Whoa! I think something's interfering with my force feedback. I wonder if Marvin's is getting glitching it out. It shouldn't be. It's running terribly. Where's that map? Oh, yeah, I got it. Just downloading the track now. You fucking clipping me getting a little Pornhub icon, you little bastard. Literally. Yeah, literally. I'm gonna have to take a break for like 2 hours, like an hour and a half, just to process some paperwork in a little bit. Just for a heads up, guys. What tires do I use? It has to be them, so. Oh no, not another togi. Fuck off. Yeah, fucking making it look like a fucking gremlin. What the hell is this track? Yeah, imagine. You've been using a VPN? Oh my god. Bro, what is this track? Oh my god. Alright, let's go outside. Game's running pretty shit. Ah! Right. There's something up with my force feedback settings. Fuck it, we'll stick with it. Maybe that's just how a car feels when you're drifting. Fucking hell. Oh, fuck. Right, it's like chunky as. Yeah, I think so. It's just like, I don't know. It's probably just how I've only got an R3, so it's not really much. Do a Counter-Strike. Oh, I remembered I don't like drifting. That's right. Silly me. Oh, yeah. Is that a drone following me? Oh no! I wanted to go back to the pits. Literally. Yeah. I don't, but I can. Bro, why is that fucking symbol in the middle of the way? Get out of my way. That's a spaz. Let's get some... I'm going to try really quickly. I'm going to replace this with my sequential shifter and then just focus on clutch work, I think. Go left-hand drive because that's the side that my shifter's on. Get a reasonable time of the day. I should turn the weather on. So I actually used to slide by fucking. I used to have a 323, a 320. Sorry. Forgot to change my shifter settings. Oh, my shifters. I haven't got my handbrake anymore! Oh, I haven't got my shifter anymore. I'm so used to hitting my shifter on that. Oh, my fucking handbrake. Let's get used to it. Oh yeah, thanks man. Oh, getting used to 3 pedals again. I keep going to hit my brake. Some excuse, insert excuse there. I'm gonna do one more lap, guys, and I have to take a break to do paperwork because it's the last day of the month. Sorry. I'll try and get back tonight in like an hour or so. Oh! Oh, no! It's what was my handbrake? Alrighty, guys, break. I'll be back in a little bit. That'll be awesome, man. Fuck yeah. Alrighty, boys, I'll see you in a little bit.